Chapter 27, Writing Equations for Lines. We are going to take the slope-intercept form that we learned from the previous chapter, and we're going to be given some information about a particular line or equation, and we're going to have to figure out what the slope and the y-intercept is. And once we have those two quantities, then we can simply plug them into this general format or the slope-intercept format, and we have our equation. Okay, so from the previous chapters, we can figure out our slope as long as we have 2 points on the line, and then once we know our slope, from that we can use the slope-intercept form and figure out the y-intercept. Once we have our m and b, then we'll be finished. Okay, in this first example, we are simply given the slope of the line and the y-intercept to start with. So the most important thing for solving this particular example is just to simply memorize the slope-intercept form of the line. Okay, and that is y equals mx plus b, where m is the slope and b is the y coordinate of the y-intercept. So with being told the slope is 1/5, then we know that m equals 1/5. And being told the y-intercept is 5, then we know that b equals 5. So we just plug these numbers into this template for the equation of a line, and we get 1/5 x plus 5. And there's our equation for the line. If we want to graph it, then we locate our y-intercept first, and from there we follow the directions of the slope, which is to say, with the slope of 1/5, we have a rise of 1, which means we go up 1 since 1 is positive, and we run 5, and since the 5 is positive, that indicates that we go to the right. So right and up for the rise. So from this y-intercept we go up 1 unit, and then we go right 1, 2, 3, 4, 5. Alright, and then from the previous chapter we learned that we only need 2 points to graph a line. So at this point we simply draw a straight line through our 2 points, and we put arrows on the ends. Okay, in this on this page, we're slowly being withheld information about the line. So at the top of this page, we're told that the slope is -2, but then we're withheld the y-intercept. We're not told what the y-intercept, we're just given a general point on the line, and you should recognize that these coordinates are not the y-intercept because x coordinate is not 0. Okay, the y-axis is located at x equals 0. So with the x coordinate of this point being -4, we know it's not the y-intercept. So what do? Well, we still write down our slope-intercept form, and we plug in what we do know, which is m is -2. And so with this particular form of the equation, we have y, x, and b for our variables. Well, if we knew what b was, we could just simply plug in the number and we'd be finished. But we don't know b. But what we do know is x and y. That is the -4 and the 5 we were given. And so in the next step, what we do is we replace y with 5 and x with -4. And now our equation only has one missing variable, and so we can solve for the b. -2 times -4 is a +8, and if we subtract 8 from both sides, we end up with the 8's canceling on the right and a -3 on the left. So in the end, b equals -3. Okay, now that we know b is -3, we simply go back to our general, slope-intercept form, y equals mx plus b. We plug in our -2 for the slope and our -3 for b, and we're finished. This is our final answer. This is the equation, equation of the line that satisfies the conditions that the slope equals -2 and it passes through the point -4, 5. Example 2 says, write an equation of a line that passes through 4, 6 and has a slope of 4. The key to this problem is knowing the slope-intercept form of a line, y equals mx plus b. We take the slope, we stick it in the place of the m, we look at our point, and you check and see whether it's the y-intercept, and it's not y-intercept, because x does not equal 0. But what we do have is an x value for a given y value, and we can replace our variables in this equation with 4 and 6. 6 takes the place of y, 4 takes the place of the x, and now the only variable missing is the b, and so we get the b by itself. And then what we'll do is we'll return to our original slope-intercept form, and we'll have our m and we'll have our b, and that will complete the equation. So to get b by itself, we subtract 16 from both sides. On the left we have a -10. On the right the 16's cancel and we're left with b, and so b is -10. If we go back up here and plug in the b, then what we get for our equation is 4x minus 10, and this is our final answer. Okay, another situation that you can run into, um, they've withheld even more information. Now they're not even telling us what the slope is. What they do is they give us 2 points on the line, and so we have to calculate the slope ourselves. The slope is calculated by dividing the difference between the y coordinates by the difference between the x coordinates. And so I pick out my y coordinates. I'll use 3 first and subtract 1. I have 3 and 1. I use the 3 first. Since I use the 3 that came from this point here, then I have to use the -4 first for the difference of the x's and subtract the 2 from it. 3 minus 1 is 2. -4 minus 2 is a -6. If I simplify this fraction, I get a -1 over 3. And so here's my slope. And in this case, I now have my slope and I have at least 1 point on the line. And so I'm back to the information that I started with in example 2, and I can simply use this same procedure to figure out what the equation of my line is. So m is -1/3, and so I take that and I insert it into the slope-intercept form of the equation. I don't have my y-intercept. Neither of these points has an x equals 0. Okay, I have 2 and -4 for my x coordinates. And so what I'm going to do is I'm going to pick one of them, it doesn't matter which one, and I'm going to take these coordinates and replace my x and y variable with them. And so y becomes 1, x becomes 2, and now all that's left in terms of variables is b. And so I can solve for my y-intercept that I need. -1/3 times 2 is -2 over 3. I add 2 over 3 to both sides, and I get 1 and 2/3 equals b, and the 2/3 on the right has canceled, okay, leaving b by itself. And so now I go back to my original slope-intercept form. I replace the m. I keep the y and the x in this case. I just replace the m, and then I replace the b with 1 and 2/3. And this completes my equation for my line. Example 3. I'm given the same situation that I worked through on the previous page. I'm given 2 points. I don't know the slope, and neither one of these points are the y-intercept because the x's are not 0 for either one. And so my first step is to figure out what my slope is. I calculate the difference of the y's, and I divide that by the difference of the x's. Okay, if I pick the 5 first and subtract the 3 for the y's, Then what I want to do is return to the coordinate, the ordered pair 5, 5, because I picked the 5 first for y, then I have to pick this 5 first for my difference in the x's. And so 5 comes first, and I subtract a negative 1 on the bottom. 5 minus 3 on the top gives me a 2, and 5 minus a minus 1 on the bottom gives me a 6, and so I end up with a positive 1/3. Okay, now what I'm going to do is take my slope-intercept form, I'm going to plug in my slope that I just found, and now I'm going to pick one of my points. I'll pick 5, 5. I'll combine these this x and y coordinate with my slope-intercept form. I get 5 equals 1/3 times 5. Both x and the y are 5. And now I have an equation where only the b is missing. Okay, so I simply solve this equation for b. I have to subtract 5/3 from each side. Okay, the 5/3 cancel on the right, and I'm left with b by itself, and so now I'm left with calculating the difference of two fractions, and I have to find a common denominator. So if I change the denominator of the 5 over 1, this just simply came from the 5 that was on the left side. If I change the denominator from a 1 to a 3, then the numerator becomes a 15. And if I subtract 5, I get 10 over 3. So 10 over 3 is b. It's my y-intercept. So to finish my equation for part A, I write y equals 1/3 x plus 10 over 3, and that completes the equation for my line. This is the line that passes through the points -1, 3 and 5, 5. Part B is very similar, but in that we're given 2 points on the line. We aren't told the slope, and we aren't told the y-intercept. Okay, in this case we still have to know the slope-intercept form of a line. It's y equals mx plus b. Okay, in this case both the slope and the y-intercept are easily determined from the graph. Where does this line intersect the y-axis? It intersects it right there. Okay, and so if each grid unit is 1, then we intersect the y-axis at y equals 2. So in other words, my b is a positive 2. Okay, how do we figure out what the slope is? M. Slope equals rise over run. Okay, what directions do we take to get from one point to the other? If I start with the point furthest to the left, then I go up 1, 2, 3, 4, 5, 6 units. Okay, once I go up 6 units, I'm completely level with the second point. And so my rise would be a positive 6, and I'm temporarily located right here, and I want to make my way to this second point, and so I count the units for my run, and I go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So run equals a plus 10 because I went to the right, and my rise equals a plus 6 because from the first point to the second one I had to go up. So I have a slope of 6/10. This is a fraction. I could simplify it to a 3 over 5, and now I simply take this quantity and I replace the m in the slope-intercept form. And so the equation for my line is y equals 3/5 x plus 2. Example 4, it reads, write an equation for the line below. Pretty much the same type of problem as the previous page. And so we're given a graph. We're given 2 points on the line. And so from the graph we have to determine m and b. Well, we are given this point on the line, and this point lies on the y-axis. And so this point is the y-intercept. And so that tells us that b equals -2. b is the y-coordinate of the y-intercept. If we were to write both coordinates for the y-intercept, that would be 0, -2. And so b is the -2, it's the y-coordinate. So we would take -2 and replace the b. And so now the question is, what is the slope? M equals rise over run. So we have to start at one point and go to the other one in completely a vertical and horizontal step. So what I'm going to do is I'm going to go right until I'm directly above the second point, and then I'm going to go down to finally arrive at the second point. So this is my first point and this is my second one. Okay, if I start at this point on the left, then I have to go 1, 2, 3, 4, 5, 6, so that I'm directly above my second point, and I'm temporarily located right here at the origin. And so going 6 to the right would indicate that my run is a +6. So being located temporarily at the origin, what do I have to do to arrive at my final point, the second point? I have to go down 2 units, and then I'm right on top of the second point. And so going down is my rise, and that means that my rise is going to be negative, and I move 2 units. A -2 over 6 can be simplified as a -1 over 3. I now have my slope. I know what my b is, and so I simply take y equals mx plus b, and I replace m with a -1/3. I keep my x and my y, and then I write a -2 in the place of b, and so I can write subtract 2. And so that completes example 4. Here is my equation that describes this line graphed above. Okay, so we've graphed quite a few lines. We've looked at all different types. We've seen some that increase from left to right. So whenever we talk about the slope, we orient ourselves to go from left to right. And so in this case, if we go from left to right, okay, then what happens to the y coordinate? Well, every point along this line is a step up from the previous one if we go from left to right. So we say this is a positive slope. It's increasing. A negative slope decreases, again, from left to right. And so as we track our way across the line, going from left to right, each step to the right results in a y that goes down. It decreases. Okay, the y coordinate drops as we go from left to right. So this is a negative slope. And as we talked about in the previous chapter, horizontal lines have a slope of 0, and vertical lines, this one here, has an undefined slope. So in example 5, we have to identify the slope of the line. So if we start on the farthest left and we trace along the line from left to right, then our y coordinate decreases. We're dropping as we go from left to right along the line. So this is a negative slope. It points down to the right, down to right. Okay, this next slope, if we start on the left and we trace along the line, then we have to move our pencil up. And so this is up to the right. It's a positive slope. Okay, this line is vertical. Okay, it's parallel with the y-axis. And so this is what we call an undefined. It's vertical. And our last line is horizontal. Okay, and the slope is 0. Okay, how can we apply this to a real world type problem? Okay, these equations, these linear equations, the slope-intercept form. Alright, we're given a question. Okay, it's about a band. It says it's going on a tour and needs to rent a bus to take all the students and instruments. The school must pay a $200 deposit up front and $75 for each day of use with the bus. Let C represent the cost to rent the bus and D represent the amount of days the band has been using the bus. Write an equation relating C to D and then graph your equation. Okay, and so the workbook simply walks us through an explanation. It tells us that we have to pay $200 up front. This is our flat rate fee. Okay, it doesn't depend on how many days that we use the bus. Okay, so it's simply going to be a constant, and in this case we typically assign the constant of a particular problem to the y-intercept, and so B is going to equal 200. Okay, so if we didn't actually use the bus any days, we could write 0, 200. And what we want to do, this is important in how we changed our ordered pair because we're not given variables x and y. We're given d, the number of days, and c, the cost to rent the bus. And so in this case, by writing d first and c second, what we're saying is that d is sort of our x variable and c is our y. And at the same time, we're saying that c, cost, depends on days. And that makes sense. Okay, the more days that we use the bus, the higher the cost. Okay, so with these type of problems, we usually home in on the flat rate fee, and we use it for our y-intercept. Okay, what about the slope? Okay, what we're trying to do is take the information in the problem and relate it to this linear slope-intercept form of an equation. Okay, and so what we've done is we've said that y is our dependent variable. Okay, we're calculating the cost, and so y is going to be replaced by the cost, c. X is going to be replaced by d, the number of days, and then we've already chosen a number, our flat rate for our y-intercept, and that works out to be 200. Okay, so in other words, if I take this equation and I replace d with 0, what happens? Okay, if I use the bus 0 days, well, if I use the bus 0 days, then I still have to pay the $200 fee. Okay, and m is simply our slope. Ultimately, it's going to be a number, and any number multiplied by 0 simply gets knocked out of the calculation. And so with d0, we get c equals 200, which is what we would expect from our y-intercept. We had the coordinates 0, 200. And so the question is, how do we complete our equation? And the only thing missing from this equation is m. Okay, so what's our slope? Well, it turns out that we were given the number 75, and $75 is what we have to pay each day that we use the bus. Okay, and so we simply take the m. Okay, we didn't really have to do any calculation. 75 is just the number that we haven't used, and 75 is related to the number of days. And so we replace m with 75, and we have our equation. Okay, cost is $75 times the number of days plus the flat rate of 200. Okay, and so they've taken this. In this case, we've plotted C on our vertical line because it's analogous to Y. And then on our horizontal axis, we've plotted D, okay, the number of days. And so the more days that we use the bus, we see that our line increases from left to right. This is a positive slope. Okay, example 6 reads, Mandy is a germaphobe and just bought an 8 fluid ounce container of Germ-X hand sanitizer. Mandy will use 1 fluid ounce of hand sanitizer every 3 days. Okay, and this is one way to pick out your slope right off the bat. When they relate one quantity, such as fluid ounces, to the number of days, okay, one quantity related to another one, that's usually a good indication of what your slope is going to be. Okay, in this case we say our slope equals 1 fluid ounce every 3 days. Would mean that we could write this per 1 fluid ounce per 3 days. Okay, and the other thing to pick up on these application problems is usually we're given some starting or initial value. Okay, in this case we're talking about hand sanitizer. Well, how much did we start with? It told us that we started with 8 fluid ounces. Okay, so starting amount is one way that you can pick out your y-intercept. In this case, we say that b equals 8. Okay, now it says write an equation relating n to d. Alright, and so what we're saying is that n depends on the number of days. So every day we use up, or every 3 days we use up 1 fluid ounce of hand sanitizer. So as the days pass, n is going to decrease. So n depends on the days, and we insert n into the place of y and d into in the place of x. Okay. The way that we usually organize our ordered pair is we put the independent variable first and the dependent variable second. Independent variable is x, dependent variable is y. And so n depends on d, and this is the way we're going to arrange our ordered pairs. Okay, so this is going to be a linear relationship. So we start with our slope-intercept form of a line, a linear equation. Alright, instead of using the generic variables x and y, we've stated that we're going to use d and n instead. And so n replaces the y, d replaces the x. Okay, our slope, our rate of hand sanitizer use was 1/3. Okay, and then we started with 8 fluid ounces. Alright, and in this case there's actually something missing from this equation. Okay, and if you reread the problem carefully, you should pick up on the fact that the sign of our slope is wrong. Okay, the second sentence says Mandy will use up. Okay, so we're decreasing the amount of hand sanitizer that we have by 1 every 3 days. We're using it up, and so our slope should have been given a negative sign. And so to fix our equation, we should write -1/3. Alright, at this point we are ready to plot our equation. Okay, now n has taken the place of the y variable, D has taken the place of the X, so N is represented along the vertical axis and D along the horizontal axis. Well, if D equals 0, in other words, if we're on the N axis, the Y axis, then where do we start out at? Where do we plot our first point? Well, if we plug in 0 days, the 0 knocks out the 1/3, and we're left with N equals 8. So at D equals 0, which is right here on the D axis, we want to go up 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. This is pretty much our y-intercept. Okay, so the units on this axis are 1, and I'll stick with that. On the d-axis, we have one grid mark on the d-axis represents 1 unit or 1 day. So to apply our slope, we want to go from n equals 8, we want to go down 1, our rise, our upper number is -1, and then our run is a +3, and so we want to go 1, 2, 3 to the right, and then we plot a point. Alright, so to graph this relationship between the number of fluid ounces of hand sanitizer and the number of days that have passed, we simply draw a straight line through the 2 points that we found. And so we can see that as the days pass, we're using our hand sanitizer up. We have a decreasing, a negative slope. Example 7 says the Sugar Sweet Company is going to transport its sugar to market. It will cost $5,500 to rent trucks, and it will cost an additional $125 for each ton of sugar transported. And so right off the bat, they gave us a fixed cost, and then they gave us a dollar amount that was related to tons of sugar. Okay, if we transport a ton of sugar, then it's going to cost us $125. If we transport 2 tons of sugar, then it would cost us 2 times 125. So if you read the problem, we have dollars and we have tons. This part, this phrase in the second sentence relates dollars to sugars, tons of sugar. That usually should indicate what your slope is going to be of your linear equation. So we'll write our slope is 125 over 1. Okay, dollars to tons. Alright, our flat rate amount, flat rate amount, or maybe that's not a good term, maybe I should say fixed cost. That's probably better. Our fixed cost. Okay, we're going to pay this regardless. We're paying at least $5,500 to rent the trucks. Okay, so it says let C represent the total cost, S represent the amount of sugar that we're going to transport. Write an equation relating C to S. Okay, so if they say relate C to S, then that means C depends on S, which makes sense. If we ship more sugar, then we're going to have to pay $125 for every ton that we ship. Okay, and that's going to be added on to our 5,500 figure. So C depends on S as Y depends on X. Okay, Y is the dependent variable, X is the independent. So if C depends on S, we take our slope-intercept form of our equation and we replace Y with C and X with S. Alright, what's our slope? Well, it's the two quantities, the dollar and the tons. It's that number that relates the two. And so we write 125 in front of the tons of sugar, and then we replace B with the 5,500. Okay, so we found our equation. So we've finished this part of the application problem. Then they want us to go back and use this equation to figure out how much is it going to cost for us to ship 16 tons of sugar. Well, we simply plug in 16 in the place of S, and we calculate it. Alright, so our equation was C times 125, or C equals 125 times S plus 5,500. We replace S with 16. We pull up our calculator and we type in 125 times 16 plus 5,500 to get $7,500. And so that pretty much answers all the questions for example 7. Example 8 reads, let Y represent the total cost for a certain calling plan. Let X represent the number of minutes of calling time used. Suppose that X and Y are related by the equation 1695 plus 0.05 times X equals Y. Okay. We want to answer the questions below. So we're given this equation already. We don't have to come up with it ourselves. We just want to interpret the slope and the y-intercept, because this is in the form of the slope-intercept. So it's just that we have the y on the right side. If we switch sides, left and right, then we get 0.05x plus 1695, which is in the same format as slope-intercept. Okay, we have a number multiplying our x variable, and then we have a number, a constant, being added to this x term. Okay, x, okay, y, let's say y is cost, x is, let's see, number of minutes of calling time used. And so what is our slope? Okay, and then we're given 1695 off to the side. Okay, and this is a dollar amount. Well, what units is the cost going to be in? Is it going to be in minutes? Is our cost going to be so many minutes? No. Our cost is going to be represented in units of dollars. Okay, so here we have $16.95, and we have to add to that a quantity that is also in dollars. You can't get you can't get your cost in terms of dollars if you add minutes to dollars. That just doesn't make any sense. Okay, and so whatever we get by multiplying m times x, we're going to end up with dollars. The only way to do that is if we have minutes on the bottom of our slope to cancel out the minutes that come from the x on the top. And so if we want to be left with dollars from x times the slope, then we're going to have dollars on the top of our slope. And so this tells us what the arrangement of our slope is. M equals the dollars divided by minutes. That's the only way to get our cost in the correct units, dollars. So, alright, what is the total cost when no calls are made? Well, that's simple. If no calls are made, that simply indicates that we've used 0 minutes, which means that x equals 0. Okay. If we take our equation, c equals 0.05 times x plus 1695, and we go back and replace x with 0, the 0 times 0.05 is going to get knocked out. And so this is going to give us our cost is $16.95. So even if we don't make any calls, we have to pay $16.95. And this is in dollars. Alright. What is the change in the total cost for each minute of calling? Well, the change in cost, what is the cost is measured in dollars. So our slope is change in dollars divided by change in minutes. Okay, and the way it's written here, we have 0.05. That is the number that sits in front of the x, 0.05. Well, we're comparing that to a fraction, and so we need to write 0.05 as a fraction, and one way to do that is just to simply put a 1 on the bottom of 0.05. And so when we compare the numerator and denominator to the structure of our slope, then you should realize that it costs 5 cents per minute, per 1 minute. 5 cents over 1. Dollars on top, minutes on the bottom. The minutes have to be on the bottom in order to cancel the minutes out that come from the x, and then we can add dollars to dollars to calculate our cost. Okay, the next part of this chapter is going to talk about parallel lines and perpendicular lines, okay, and how these terms are related to the slope. Okay, If you have two parallel lines, then that means they run along in the same direction, sort of like this. Okay, and previously in the same chapter we talked about the different types of slopes. Well, what kind of slope is this first line on the left side? Well, if we go from left to right, it points upward. Okay, as we trace along this line, it points upward. So this slope is positive. Okay, this line is identical to that one, except it's shifted over to the side. It points in the same direction. So if we go from left to right along this second one, its slope is also positive. It's the same type of slope. And if we say these are parallel and they have the identical directions, then they actually have the same number. They're not just both positive numbers. Alright, and so if this slope of our first line is 2, then the slope of our second line, M2, is also going to be 2. Okay, and 2 is just arbitrary. If I said these two lines were parallel and I instead said that the first line had a slope of 5, then the slope of the parallel line M2 has to be the same exact value, a positive 5. Okay, perpendicular lines. These lines meet at 90 degrees. They're exactly like the X and Y axis, except they don't have to be oriented to where one is vertical and the other one is horizontal. They can have different slopes. So likewise, these are lines that are perpendicular, so they meet to form 4 90-degree angles. Okay. How are perpendicular lines related to the slope? Well, it turns out that if we have the slope of one line, say this is M1, okay, and let's say that this one that points up to the left is M1, then to figure out, better yet, let me say this other one, okay, because 2 is a positive number and our positive slope in this case is the one that points up to the right. So let's say this is M1. If this is M1 and its slope is 2, and then this second line is drawn such that it's perpendicular to line 1, then all I have to do, if I know that they're perpendicular, is flip M1 slope. Okay, M1 can be written in terms of a fraction, 2 over 1. To get the perpendicular slope, I flip the fraction and I write 1 over 2, and then I also change the sign, and so this slope is positive, my perpendicular slope would be negative, which makes sense because this one points down to the right. Okay, and so we say that perpendicular lines have slopes that are negative reciprocals of one another. Okay, so we have a question. What are 3 pairs of negative reciprocal numbers? Let's say we have negative 3 over 2. Okay, what is the negative reciprocal of negative 2 over 3? Well, we flip the fraction upside down and we change the sign, we make it positive. So these are negative reciprocals of each other. Let's say we have a 1/5. What's the negative reciprocal of 1/5? Well, we simply write 1 in the denominator and 5 in the numerator, and 1/5 started out as positive, so I make this negative. So negative 5 is the negative reciprocal of 1/5. Okay. What if we have 2? Or we've already seen 2. Let me say, what if we have 4? Well, the negative reciprocal of 4 would be 1 over 4, and it would be negative. Okay, we change the sign from positive to negative, and we flip the number 4 upside down, and so we now have a 1 over 4. Okay, what is the negative reciprocal of 0? In other words, think of it this way. Okay, if we have a perpendicular line or a horizontal line, then we have a slope of 0. Okay, the line that's perpendicular to that would be a completely vertical line. What's the slope of a vertical line? It's undefined. So the negative reciprocal of 0 is undefined. If we write 0 as a fraction, we get 0 divided by 1. And if we take the negative reciprocal, then we write 1 over 0, which is undefined. Alright, example 9. Finding slopes of lines parallel and perpendicular to a given line in the form ax plus by equals c. Alright, what is the slope of a line parallel to this line? Okay, we'll write m with parallel lines below it. M parallel equals same slope. Alright, so first we have to know what the slope of this line that we're given is. The easiest way to figure out the slope of this line is to put it in y-intercept or slope-intercept format. Right now it's in the general form. So we take 9x minus 8y equals 6, and we get the y by itself. This leaves us with negative 8y equals negative 9x plus 6. And to get the y by itself, our last step is to divide by negative 8. Negative 8 cancels, and we end up with y equals 9 over 8x minus 6 over 8. What's the slope of this line? Well, now that it's in slope-intercept form, the slope is 9 over 8. It's the number that sits in front of the x in the slope-intercept form. So the parallel slope we put these parallel lines, this label beside the m. It's the same slope as the line we're given, and so we simply write the parallel slope is 9 over 8. Okay, what is the perpendicular slope? And so we simply label the m with a set of perpendicular lines. Okay, this is going to be our symbol for perpendicular slope. It's the negative reciprocal of the original slope, and so we would write negative 8 over 9. Our slope was positive, we changed the sign, and then we swap the numerator and denominator and write 8 over 9. Okay, So most of the work was done in the first question. Okay, we had to find the slope of the line that we were given, and then we can figure out what is the parallel slope and what is the perpendicular slope. Example 10, writing equations of lines parallel and perpendicular to a given line through a point. Okay, we consider this line 9x minus 4y equals negative 8. So our first step is to figure out the slope of the line that we're given. So the easiest way to do that is to put it in slope-intercept form. We move everything away from the y, so we subtract the 9x from both sides first. We end up with negative 4y equals negative 9x minus 8. Okay. Now we take this equation. To finally get the y by itself, we divide by negative 4. Negative 4's cancel, and we get y equals 9 over 4, and negative 8 divided by negative 4 is plus 2. So our slope of our original line, slope original, is 9/4. Okay. Now, what is the perpendicular slope? Ultimately, we want the equation of the line that is perpendicular and passes through this point. Well, we're going to use the slope-intercept form for this new equation. Okay, this is perpendicular line. Okay, don't get it confused with this original one. This is our new equation. Alright, the first step is to figure out the perpendicular slope. So m perpendicular equals negative 4 over 9, negative reciprocal of the original slope. We replace the m in this equation. How do we find the b? Okay, so to finish the equation for any line, there's two things that you need. You need the number m and you need the number b, and you're done. All you have to do is stick those numbers in these places and keep your x and y. Well, we're missing a number. Only thing we know is the slope. And so we have to figure out a way to solve for the b. Alright, we worked a problem like this earlier in the chapter. We said that, well, we don't have the y-intercept, the b, and the coordinates that we were given for this line do not contain x equals 0. So this isn't the y-intercept. But what we can do with these coordinates is replace the y variable in our equation and the x with the 6. And now we have an equation with the b as being our only variable. So what we do at this point is we solve for b. Negative 4 over 9 times 6 is negative 24 over 9. To get b, I add 24 over 9 to both sides. This could easily be done with your calculator. And so what do we get? pull up my calculator. 1 plus 24 over 9, enter. 0.66666 repeated is 2/3. So 1 plus 24 over 9 is 3 2/3. And this was the last piece of the puzzle that we needed. We know our perpendicular slope. We know that it passes through this 0.61 because we use those coordinates for x and y. And we now have the y-intercept that's associated with this slope in these coordinates. And so we simply take our slope-intercept form, y equals mx plus b, and we only replace the slope and the b. And we're finished. -4/9 is our slope, and 3 2/3 is our y-intercept. Okay, so the second part, new conditions. Okay, we want the line that's parallel and then passes through the 0.61. Okay, here is our template for our parallel line. And we start the same way we do with any problem where we want to figure out the equation of a line. We plug in our parallel slope. So this is m parallel, meaning it has the same slope as this original line, which was 9/4. Okay, now we take the coordinate 6, 1 and we replace the x and y of our equation. And you're going to figure out that we can't just simply use the b that we calculated in part A. We're going to get a different y-intercept. So we calculate 9 times 6 and we get 54/4. To get the b by itself, we subtract 54/4 from both sides. Cancels. And so we get b equals, okay, this canceled, we bring the b down. What is 1 minus 54/4? We won't fool around with the fractions. We'll just use our calculator to figure this out. We have 1 minus 54/4, enter. And we get -12.5. And like part A, this was the last piece of the puzzle. We take the slope-intercept form of an equation. Any equation will fit this form. And now we just want to give it the slope that we need, the parallel slope, 9/4, and our specific y-intercept, 12.4. And like I said, this one is different than the one that we found in part A. Okay, so whenever they say that you want a parallel line, a different slope, but still pass through the same point, you have to work through the entire procedure again. Example 11. Identifying parallel and perpendicular lines from equations. The equations of 3 lines are given below. Okay, And then at the bottom it says, for each pair of lines, determine whether the lines are parallel, perpendicular, or neither. So, we want to know the slopes. That's the only way to figure out whether they're parallel, perpendicular, or neither. We need the slope of each three of these lines. Alright, there's no work to do for line 2. You just simply have to recognize that this is in the slope-intercept form. Y is by itself. We have a single number in front of the x, and then we have a constant being added to the x term. And so to pick out the slope, we just pick up the number in front of the x. Slope equals -4/3. Now, this was the easy one. We need to take line 1 and 3 and put it in this slope-intercept form so that we can figure out what their slopes are. Well, this one, the x is already on the right side, but we have this 3 sitting in front of the y. So what we do is we just divide the 3 to get rid of it. We divide everything in the equation by 3, and this gives us our y by itself on the left. And now we have a -4/3 in front of the x, and our y-intercept is 5/3. Alright, and so this number is our slope. M equals -4/3. Okay, so this is slope 1, this is slope 2, and finally, what is slope 3? Alright, we take this equation and we solve for y. Divide by -8 everything in the equation. The -8 cancels, and we get y equals 6/8 x plus, well, the 7's being divided by -8, and so what we could write is a minus, subtract 7/8. Now, we want to take every slope that we have and write it in simplest terms, because most of the time we have a fraction for our slope. So I'll rewrite this as a 3/4x. Okay, and so now we see that they actually have this slope actually has similar numbers to the other ones that we found. Okay, M3 is 3/4. Okay, so let's compare line 1 and line 2. M1 is -4/3, and M2 is the same thing, -4/3. When the slopes of two lines are the same, then we say that they are parallel. What about line 1 and line 3? Well, M1 is -4/3, and M3 is 3/4. If you compare the two fractions, then you can see that the 4 and the 3 have been swapped, and the numbers change signs from a negative to a positive. So these are negative reciprocals of one another, which tells us that these two lines, 1 and 3, are perpendicular. Okay, what about line 2 and line 3? Slope 2 is also -4/3, and then slope 3 is 3/4. So just like 1 and 3, 2 and 3 are also negative reciprocals. The 4 and 3 swap places for 3/4, and then we go from a negative slope to a positive. 2 and 3 are also perpendicular. That completes example 11, and this also completes chapter 27. Thanks for watching.